In the last video, we dove into installing Comfy UI and got it running with a low VRAM workflow. Today, we're diving even deeper. I'm going to show you how to create stunning images like this, and this, all in just 8 steps using the Flux def model. We'll also look at how to get better text in Flux, another method of upscaling that's kinder on your GPU, and the one group I include in all my image generation workflows. Now, the good news is we've got Flux running on a low-end PC with 6 to 8 gigabytes of VRAM and minimal system RAM. The bad news? It's still a bit slow. Even after reducing system strain with the quantized model, the upscaler kind of pushed those times right back up again. In this video, we'll slash that time in half. But before we start, just a heads up, everything on this channel is going to be focused on low-end systems, at least for now. So if you don't see me covering something, it's probably because it won't run well on a low VRAM system. All right, let's jump in. There are a few models we need to download first. The first one is a new clip encode model for Flux. This will improve its already solid text capabilities. You don't need to worry about it too much right now. We'll circle back to this in a bit. The link is in the description. Go ahead, copy and paste it into your browser, hit enter, and download the improved version. You'll want to save that in the model's clip folder. Next up, we've got the Hyper Lora to speed up Flux. Again, the link is in the description. Download the 8-step saved and source file and drop it into the model's Lora folder. And finally, we've got the Flux def add details Lora. Same process, copy the link, download, and drop it in the model's Lora folder. Once you've got all that sorted, we're good to go. First, drag the updated version of the workflow into Comfy UI. If you have nodes missing, you'll see them highlighted red. Open the manager, click on install missing nodes, choose them all, and click on install. Don't forget to restart Comfy UI. Let's select the new clip encode model in the dual clip encoder. Then add and enable both the Hyper and Add Detail Loras in the CR Lora stack. The good news is that neither of these Loras needs trigger words. For weights, set the Hyper model weight to 0.12. I tried higher, but it resulted in some burned images, especially around 0.7. The Add Detail Lora works best at 0.7 for optimal results. So what does this Hyper Lora do? It lets you generate solid images with fewer steps, just like the Hyper SD XL Loras, but with a key difference: consistency. I never really got great results with the previous Hyper Loras, but Flux is a whole different story. Flux at the moment has 2 Hyper Loras, one for 16 steps and one for 8. My advice is simple: stick with the 8-step Hyper Lora. Flux already gives great images at 16 steps without requiring one. Now, before we go any further, let's clear something up. The Flux Hyper Lora isn't some magic wand that lowers the strain on your GPU or RAM. What it does do is reduce your step count from 20 steps to just 8 in my case, which speeds things up considerably. Now, about the workflow changes. First up is the remove objects group, and then there's the latent upscale group. Let's generate an image using the following prompt and see what the Flux Hyper Lora can do with just 8 steps. Capture a hyper-detailed, towering Gundam robot standing in a mystical forest, surrounded by ancient, massive trees with glowing bioluminescent vines hanging from the branches. The robot's metallic surface reflects the soft, ethereal light filtering through the dense canopy. In the foreground, a tranquil mist-covered pond reflects the Gundam's silhouette, while faint, mysterious blue and green magical orbs float in the air. Shot with a 50mm lens at f2.8 for a natural depth of field, emphasizing the robot's intricate armor while subtly blurring the magical background. Natural soft light gives a dreamlike glow, with low ISO to maintain clarity and detail. Set the steps to 8, guidance at 2.5, sampler name Euler, Max shift 0.7, base shift 0.4, and SGM uniform as the scheduler. Let's queue it up and see what we get. Alright, not bad at all. The fact that we only needed 8 steps is awesome. A complete reduction of 12 steps. Quick reminder, if you're on a system with only 8 gigabytes of VRAM, make sure nothing else but Comfy UI is running. Okay, now let's talk about the latent upscale method. In the last video, we used the ultimate SD upscaler, but that took forever. This time, we're trying something new, the Pixel K sample upscale. It's faster, which is key when you're working with limited hardware. You've got 2 options here. You can either use the image generated from the text to image group, or you can upload an image through the load image node. I've also included the Lava captioner in this workflow. It's super handy. What this does is it uses the Lava 1.5 models to extract an image description and give you more detailed instructions. The reason I'm not using Florence 2 here is that I wanted to give more instruction to the model on what exactly it should do. The switch here lets you toggle between the text-to-image latent and the upload image latent. 1 is for text-to-image, and 2 is for the upload image node. You'll find the download links for the Lava models in the description as well. Just paste them in your browser and they will download automatically. And once they're downloaded, place them in the model's Lava checkpoints folder. Now onto the actual latent upscale process. You'll start by copying the prompt from the text to image and paste it into the text to image prompt text box in the latent upscale. Then choose an upscale model. I'll be using the foolhardy upscale model. Next is the Pixel K sample upscale provider. Set it to 2 steps with a CFG of 1 Euler CFG++ as the sampler, the noise at 0.25 and tile size at 512. For the seed, copy it from the text to image above and make sure it's fixed. The iterative upscale factor should be at 1.5, and for some added sharpness, I got an image sharpener set to 0.50 at the end. You can bypass that if you want, but I like the crispness it adds to digital art. Before we hit go, make sure the latent upscale switch is set to 1 so it uses the image we just generated in the text to image. Set the get image source to text to image. Bypass the Lava captioner. Let's queue it up and see what happens. The results, honestly, amazing. If you want more detail, bump the steps up to 4. It'll still be quicker than the previous method. If you're planning to use an image you've already generated, just switch the latent upscale switch to 2 and change the get image source to upload image source, activate the Lava captioner, and then queue. Remember, you can either bypass the sharpener if you want to. Now, there's one more thing I want to talk about before we wrap up. The new clip model we downloaded earlier. Let's see if there's a difference between the old and the new clip model using this prompt. A hyper-realistic close-up of a blue and white Gundam robot holding a cardboard sign that says hyperfast with speed written below. The robot's faceplate and hand are detailed with scuffs and wear, as if it's been through many battles. The cardboard is slightly bent and wrinkled, adding to the realism of the scene. Shot at f2.8 to create a shallow depth of field, focusing on the text and the robot's hand, while the background, a futuristic city street, blurs out. Lighting comes from above, casting subtle shadows on the robot's metallic surface. The mood is determined and intense, with the message of speed and urgency conveyed through the robot's imposing posture. And the result, the difference with the new clip model, honestly, not noticeable. But there are those that swear by it, so definitely worth keeping around. I feel like it will really show its true power if the text is complicated and long. And finally, the object removal group I mentioned earlier. Let's say you generate an image and it throws in something random like a beach ball you didn't ask for. Just right-click, open it in the mask editor, select the object, apply Q, and the ball's gone. It's not 100% perfect, but when it works, it works. Note that the model downloads automatically when you run it for the first time. That's it for today. I wanted to dive into control nets, but I've been having some issues, so that's coming in a future video. If there's something in Comfy UI giving you trouble, let me know, and I'll try to cover it next time. Thanks for watching, and don't forget to like, subscribe, and hit that bell so you don't miss the next one. Catch you later.